Okay, welcome back. So we have the x-axis, x carriage. Let me see what's next. Make sure this is not in frame. Okay, cool. Hello, one viewer, whoever that is. I will try to interact as much as possible. View the chat. Okay. So let me go find the printed parts box, which I think is this one. Okay. For x-axis, there's 3 parts. These are large parts. So I don't see too many problems with these, so they must be pretty clean when they're printed. Doesn't even look like they reamed the holes, which the bridging is pretty insane. They bridged this top gap. Anyway, and this is a really complicated part. This is the X carriage, and it doesn't even look like they do much cleanup at all. I don't think they clean up these parts. I don't think they have to. They're a little sharp on the edges, which if I was really anal about it, I could do it, but I don't think it's going to affect this printer build. Anything else I can get with a pocket knife. As long as the hole tolerances are good and the bearings are, straight, I think that's all we really need. Looks like there's some places to put like a bearing, like the wire clipping here. So I think the wiring is all going through these little channels. So that's the first step. Let me get my tools out. Tools are in this box. I sorted all the spare parts out. They use glue stick, some electronics, for the extruder, Z-axis, X-axis. We'll pull that out. Just a bunch of bearings, spares. I need those spares. Here's all my tools. So, tools, spare bags, etc. I don't need everything right now, so I'll just clean it up. So we just need a pair of pliers and a 2.5-inch hex wrench, which I don't know what that is, but I'm assuming it's one of these. Okay. Next step. I'm going to go faster since it took me 5 hours to get through this part, and I pretty much accounted for this build only be taking me 10 hours. I think 10 hours is probably a good estimate of time from what I hear, but who knows. And I'm still eating this candy for some reason. It's pretty gross. Oh, we need rods. Okay. The rods are in this tube. Okay, they're a little longer rods. Put the Z rods back. So I don't know if these are chromed rods. They don't look like they're chromed. They look like they're steel, just fresh steel rods, which should be fine as long as I keep them lubricated. So the X-axis has 5 bearings. 3 of them are gonna go on here, on these rods. Crap load of zip ties. God, this printer, you better buy stock in zip ties if you're gonna build this from scratch. Let me see if you can see everything. I'm gonna move this this window up here over. Okay. There. That might be better. I don't know if you can see. Looks like this is the prime area, so that's the hard thing about doing these live streams, is I don't know where my camera is pointing. The best idea is to have a live monitor next to the camera so I can see what it's doing in real time. And I think I need to do a wide angle. I did get a tripod though, so this will be a little bit easier for us. They do have tapered ends, so the bearing should easily slide in. You want to carefully put your bearings in. You know what I like about this is they probably get these cheap bearings from China, like everybody else does. But when I bought my bearings, half of them did not fit on the rods. They either fit, or they're really grindy, or they are too loose. This one's really grindy, but they're kind of grindy, but I mean, they're not consistent at all. But I mean, as long as they're not binding and they're not giving you a lot of like free load tolerances. You can kind of feel a little bit of play, like minute amount of play, but this one doesn't have any play, and they're smooth. I think it's just the lubrication and the tolerances of the balls and the tolerances of the rods. So it seems pretty good. I'm just surprised because that was one of the biggest issues I had with the Mendel 90 was getting the bearings that fit the rods. And I went through a couple different sources. I went through Folger Tech through eBay. So I bought Folger Tech chromed rods, and I also bought Folger Tech just stainless rods, and they seemed about the same. So, and I think it's just kind of matching your bearings to your rods. That's really what it is. My thing about, see, this is a kind of, these aren't the best ball bearings. And I think they give you a spare in the bag, so I'm going to try matching these. See, that's a little bit better. Okay. So they say carefully slide the billings bearings in the rod. Now prepare the printed parts. Insert the LM8UU bearings into the printed parts X end motor and X end idler, and shown in the pictures. So this is very similar to the Mendel 90. I think a lot of the Mendel 90 design came from the Prusa i3 design. There's even conversion files on the GitHub for converting a Prusa to a Mendel 90. I think they're about the same. I don't really think there's much of a difference. You can press on the flat surface for easier insertion. So, ta-da! It's pressed in. Let's press this one in. There. Bearings in the block. There's this one. It even shows you the. I like that they show you kind of step by step and pictures as well, in case it gets lost in translation. Especially for orientation of what you're doing, because some of these things have to be specific orientation, and if you're not careful. The worst thing is losing a ball bearing. This one doesn't have a perfectly flat side, but seems good. I do have a whole bunch of extra ball bearings though, like this would not be a bad thing if I lost one. Okay, so that stuff's done. Preparing the tension screws. Okay. Avoid over-tightening the screws. Insert. Ooh, that's weird. Insert M3 square nuts. So these are M3 square nuts. You can't really see them by the picture, but there's these really tiny square nuts basically. And those, that's a better way of doing this kit, in my opinion, is using square nuts for capture nuts, because it's easier to design a square hole than it is to design a hexagonal hole, in my opinion. Probably since this is done in OpenSCAD, it's not any different because you can just tell it how many facets you want on your object. I am really curious about designing stuff in OpenSCAD, especially to this complexity level. But in actuality, like a lot of this is really geometric, and I think since you made it parametric, like everything's constrained. So I'm imagining designing this is not as difficult as it seems, because I would like to go in OpenSCAD and actually fix some of these parts in the future, like to modify it. Let's say, and I'm sure this has already been done, but let's say a dual carriage, widen the carriage so that you can have dual extruders. That probably wouldn't be too difficult of an issue, just by adjusting the width of the carriage in the software. Everything should be parametrically matched. Or I could also combine two of the same carriages, add two more bearings. I don't know how that would work, but that's the whole cool thing about parametric modeling, is that you can go back and fix your mistakes. Okay, place M3 by 10 screws. So M3 by 10. These are 10 millimeters. They're the shorter ones that come in the bag. And those screw right in there. So it looks like there's just enough tolerance so that if the print doesn't go well, those square nuts can actually fit properly. I'm not actually sure what this is for. Oh, I know what they're for. These screws that we're putting in, I'm probably getting ahead of myself, but these are actually the hold to keep. Oops. These are basically to keep the um, these are to keep the ends of the rods from. These are basically the tension, the ends of the rods on each side of the x-axis. I'm not quite sure why you'd want to do that, but that's something that the Mendel 90 doesn't really do. He just clamps them on both sides of four, like these little bar clamps. But the x-axis rods can shift, and I think what happens is if they're loose, the whole rod will shift with the bearing as it's printing, and that might cause issues. I'm not quite sure why, but just a little detail that they're adding to it. Again, I've built enough printers that I can kind of figure out why they designed things the way they did. I would like to build my own printer at some point, but I think Prusa has like 5 years on me, 6 years on me in designing printers. I'm also doing this live stream at midnight because I'm crazy, and I also work a night job. So this is the time I get off. And I go run to my apartment, go back to the makerspace to get a laptop and a tripod. Yeah, so. So it actually looks like you have to put these screws in one side but not the other. Okay, that makes sense. So these are just to basically adjust for any slop in the cut of these rods. I'm not sure. It looks like these things are cut with a and they're pre-cut like with an industrial bandsaw or something. They're really cleanly cut on the ends, so I'm sure there's some machine that they use. Okay. Assemble x-axis base. Okay, so this is pretty important. Insert the rods with the bearings fully into the printed parts. So it looks by this orientation and this orientation. Ensure the correct orientation of the parts and the rods. The rods with 2 bearings must be on the side with the nut traps. Nut traps. Insert the rods very carefully. Do not tilt the rods too much. Okay, I don't know what they call which nut trap they're referring to, but let's insert. I'm gonna just check this other picture. Oh, that nut trap. So this is for the z-axis. That's what it's supposed to look like, though. I guess these are considered nut traps, and I think these are to keep the z-axis from backing out. What's interesting about this that the Mendel 90 doesn't do is, oh wow, that's a tight fit, is that the Mendel 90, the Z-rods can actually get out of sync, and because these are such a tight pitch, I've watched during calibration, they tell you to move the y-axis, the z-axis all the way up until it basically makes the motor skip step on both sides, and that's the only way to that's an easier way to calibrate both being level. I have to do that pretty much manually. I just have to home at the top and then kind of manually adjust the rods, hold one, and adjust the Z-rods until they're basically level. And the only way I could tell they're level is just taking like a dial indicator and measuring the distance between the Z hops on the top and then the carriages. Anyway, this is another nice little tidbit here, but okay. Step 2, put these in here. So I don't want to like oh wow, that was so easy. God, this is nice. Okay. Okay. Well, that was the easiest step. Okay, what's next? Okay. This looks pretty crucial. Preparing the Y end idler. Again, very nice machined idler gear, or idler pulley. M3 by 18. M3 8 by 18. Hold on, I'm gonna go further in this. Okay. I'm just making sure these are M3 by 18s. So we need a nylock nut, one of these small screws, okay. I'm gonna actually move the carriage a little bit further because it doesn't look like it's in the frame. Again, I'm trying to get you guys a good video here. Because my last one I noticed, I watched the video from the last time, and I could see some of my mistakes from the last one. Oh, okay. Well, it looks like it goes in here. Let's put this out. Okay, screw it. It doesn't matter which way because the bearing is actually centered in this hole. It looks like the nut is going to go on the outside. Or the back side here. This would be the back technically. Secured in position with 8 screw, tighten the nut. Okay. So the back side is going to have the nut. Front side is going to have the screw. So this is the front side. Oh God, this is so easy. This is so much easier than Mendel. I think the Mendel would be easy if I followed his kit, but a lot of it was because I was custom making some parts while I was doing it. That made it really difficult. Again, I'm not going to over tighten this because all it is a bearing holder. It just has to screw tightly enough to hold the nylock. Also, this PLA can like bow. Okay, it's not moving at all. Cool. Yeah, like you definitely don't want to over tighten anything in here because it's supposed to be loose. I don't know how he's gonna tension the belt, and I'm assuming he's just gonna have me rotate the engine or the motor, like to tension the belt. Or I think there's a belt tensioner here. Okay. I like screw belt tensioners where you can adjust them while it's on the machine instead of having to like take apart the machine basically to tension a belt, because you never know when you have to retension a belt. But it's really hard to design these things without having to make it so you have to take everything apart in order. Yeah. Okay. Repairing the X carriage. This is where we need all those stupid zip ties. Zip ties are actually pretty amazing if you think about it. Insert zip ties into carriage as shown in the picture. Ensure that the orientation of the zip ties. So it looks like the zip tie heads are going to be facing outward. Oh, actually not. There's one, there's two. Oh, that's impressive. So the zip tie channels are actually inside the part, underneath the bearing mounts. So if I look inside here, it's actually transparent. You can't really see it that well, but if I had my flashlight, I would show you. Fortunately, my flashlight doesn't have a battery. Okay. Actually, let me show you. What is my phone? Let's see if you can see this. Oh yeah, it's super washed out. Okay, so you can kind of see here, you can actually see the zip tie channels through the infill. So there's infill and then zip tie channel and infill zip tie channel. Wow. I thought that was cool at the time. Okay. Kill my battery. Full size image. I like that they give you the full resolution image. This would be impossible to do without that. Those go in perfectly. The tolerance on, so the impressive thing is the tolerance of these prints. I had, when I first built my Mendel 90, like I had really impressive quality, like it had really good quality, probably better than this or a little bit like nicer looking this with ABS, but the hole tolerances were just horrible. And I even measured printed calibration cubes trying to find, any tolerance issues, and it was only like 0.1 millimeter off. I think he either designs a lot of over tolerances in here but some of these small parts, like the 8 millimeter rods fitting perfectly in here, either he's oversized them enough so that the plastic shrinks, or like he's figured out the tolerances, or the printer actually can print high tolerances. I don't really know. That's either way, it's really cool to like not have to clean up a part. This is why I tell people that want to design, they want dual extruders, they want dual extruders, they want a gigantic, meter by meter by meter size bed. Like, it's really unreasonable because unless you're gonna spend a couple $1,000s in parts, you're not gonna get this tolerance out of that gigantic bed because you're moving a giant head around or an x-axis. Core XY might have the tolerance, but I think you're still going to have resonance issues with Core XYs. I mean, why do that when you can buy a $700 printer, print half of a large part, and then just glue the two large parts together? This still has like almost a 10-inch wide bed. And then like dual extruders, it's really cool to be able to dissolve support material, but I haven't seen too many people use them or do it. Everybody shows you a dual color, and it looks cool, but it's just not. It's not something I'd like want to mess with. If I can design stuff to be in two parts, like, why not do that? Um, I mean, that's what injection molding machines do. You don't see injection molding machines do dual color. The only thing I see dual color is if you're doing double shot keys keyboards. They take a white die, like for the legend, as the mold impression of a legend, and then they put those back in the mold and then pour the or inject the plastic around that, and then you're left with the white part sticking through the blue part or whatever the color is. It makes the legends not wear, because normal legends are just printed on, a screen printed or the lasered on, and it just prevents wear. Um, Either way, it's still cool, but I think it's kind of gimmicky. Like, there's definitely uses for dual extruders, especially on the Stratasys machines. But it's still, you got to put it in the chemical bath. You got to wash it off. All that support material is just wasted. You could basically waste like hundreds of dollars worth of plastic for support material that could have easily. And they use rafts. Like, these are printed without a raft, without support material, and they do the same purpose. And they actually have better quality, in my opinion, than some of the Stratasys machines I've seen, or at least the U prints. I don't know anything about their other support materials, but I know they're big commercial machines. You still have to remove support material or wash it off. So I don't think there's any good way to do it other than design. I've done my share of support material though, tons and tons of support material. Place X carriage on the X base as shown in the picture. Ensure the correct orientation X carriage. Okay, so again, ooh, what does that say? Open original? View the original, view metadata. Let's view metadata. Oh, cool. Huge. Does it show me like the original value? God, that is so nice. Let's view original. Oh, so just the zoomed in version. That's cool. So he must have like a white box that he has lights and cameras on. I thought about that for myself. I don't like that one. This is probably going to be noisy just because of the bearings, like, and the fan. I think the fan will be the noisiest part, and the other ones will be the most annoying. Okay, I'm being really picky about the bearings, but I think they'll wear themselves in. The bearings have a little bit of slop, but I think with the zip ties, you tighten the zip ties to death, it's probably fine. Okay. Oh, doesn't hold. Okay. Next step. Looks like they break a support structure off of this one. I might cut that off. Tighten the X carriage. Use pliers to put them. Make sure the bearings are in position as shown in the picture. Bearings should be as deep into the carriage as possible. So that's how you zip tie them. And you zip tie them this orientation. So I'm kind of in the design philosophy is if I design one of these printers, um, I am gonna spend the extra money to buy actual bearing blocks. I don't like raw ball bearing 808 these style bearings. I rather just if you're gonna source them from the same place, source them from the place that has actual machine blocks that the ball carriages are in. That way you have 4 mounting points, and then you could just make a single plate that the mounting bearing blocks mount to. I think some of the Chinese clones use that, but I want to get the ones from IGUS that actually are they're captured IGUS bearings. They're probably going to be like $20 each, but you know, if you spend $60 for a carriage that doesn't make noise and has tight tolerances, it might be worth it. That's why you're going to spend a lot of money on your own printer. For kids, this is fun. I've never used pliers to zip tie stuff, but there you go. I think that's quite tight. Looks like he's just pulling it, but that's not really practical. Whatever. Cut. If it messes up, I'll just zip tie more. Okay, that's not working. When in doubt, use your multi-tool. That's my lesson. Okay. I can get them better with these little scissors than I can with those pliers. So, okay. Make sure it's seated all the way into the block. That is seated, so far seated in there. It's not going anywhere. Okay. And then these get pushed, zip tied, like so. Those are quite tight. Don't think that bearing's go anywhere. That's the tip. Okay. Cool if you could use those extra zip tie snips for something cool like more 3D printers. Okay. Oh god. Looks like this is a cable bundle. So I'm gonna make that clear, that clear. There. The carriage is noisy, but yeah, it works. Again, that's why I think, see the Taz Mini and the Taz 6 and Taz 5, they use the LM10 UU like equivalent IGOS bushings, and I think they do it where they actually capture the whole thing. They don't use zip ties. I think they put the whole thing in a compressed, like printed part. I have to look at it, but I honestly would probably go with the Taz design, but with some modifications. If I was going to make my own, but I'm going for more of a Core XY. I want to still explore Delta printers because I like Delta printers, but I don't think they're practical. The more I work on them and the more I have of these Delta printers, the less I actually want to like go forward with that design. I think there's a lot more cooler stuff you can do with a XYZ printer. But I like to explore different mechanisms. Oh yeah, now they show you how to cut the zip ties. Yep, that's in position. Cool. Okay. Oh no, not the fun part. Motor. M18 wrist screws. X motor. So this is one cool feature that I'd probably borrow the idea if I started making my own printer. Is I'd figure out how to modify our laser cutter to etch our logo in the back of motors. Either that or I would probably sticker everything, but this is really cool. Not only that, but they got black motors so that they blend in with the black and orange style. Because it's kind of ugly to see like a whole bunch of different colored wires and screws and everything. Black screws, black motor. I'd even get black aluminum shafts, but they'd probably wear down. So chrome looks fine, but the wire orientation probably matters. Yeah, here it is. Ensure correct position of the cables. Cables should face downward. Okay. This should be the correct orientation. Oh, it mounts to the back, of course. So nice. So nice. I don't think, no. I was using the wrong size screw. Ta-da! Yeah, this is definitely the fun part of building a printer. The non-fun part is actually putting the putting calibration and you figure out why your printer isn't printing. The troubleshooting part, basically. It's kind of fun. I enjoy it, but it's definitely not the most fun part. The most fun part is actually printing upgrade parts with your own printer. Getting it tuned so that you can print replacement parts with the printer itself. It looks like I'm getting like dirt in my parts. It scrapes off, but I think I'm going to take some mild rubbing alcohol and clean these parts before I put them on. They're just a little dirty. I want this to be a really nice looking printer, of course. That's probably going to go in some enclosure somewhere. Probably will not see the light of day, but hey, it's a printer. Okay. Place GT212 pulley on the X motor shaft. Adjust the position as shown in the picture. Effectively, part of the pulley should be in the axis with the screw motor end cut out and once of the screws on the pulley should face direction of the motor shaft. Oh, that's weird. That way? I don't know how they have this oriented. Maybe it's on the carriage. Huh. Weird. I think I need to read that better. So it should be on the D shaft. Wire sticking up. Adjust the position as seen in the picture. Effective part of the pulley. So the pulley teeth should be in axis with the X motor X end motor cut out one of the screws on the pulley. Should face directly on pad of the V shaft. Oh. Okay. So it's just making you eyeball where the shaft should be, which is basically exactly centered. Again, my eyes kind of distort things, but I'm assuming that's it. So I'll just tighten it. Tighten it. So I said before, it's probably a good idea to use metal pulleys, especially like machine ones like this, because I used Delrin or some other kind of pulley that was plastic, and it wasn't tightly, the screws backed out, and it wasn't tightly mounted on the y-axis shaft, and then it started skipping steps and I couldn't figure it out, and I smelled something burning, and it smelled really bad, and I checked it out. It ended up basically, the pulley ended up causing so much friction on the motor shaft that it started burning and making really nasty smell. And so I took the grub screw out and used Loctite to get the screw back in. And it seemed to hold, but that was kind of one of those troubleshooting steps that I went through. Okay. Assembling the X end stop. M2 screws. Place the end stop on the printed part and insert M6 screws. Ensure correct position in the picture. The button on the end stop has to be aligned with the key on the X motor end. Oh, that's cool. So there's a little notch, which is the key. The key is where the button actually is. So we go open our box, end stop, which has a nice. This reminds me of Beetlejuice. The white and black striped theme reminds me of Beetlejuice. So it would be, see, that's the cool thing. If I did have dual extruders, I would be printing like odd 90s, pop color things like Beetlejuice and what else? Pretty much everything from the 90s was pop colors. These are tiny, tiny, tiny little scrolls. I'm hoping that they thread in to the plastic. I'm going to use this tiny little hex driver. Okay, I'm still streaming. Nobody said hi. Okay, good. Come on. Philbot. Need to get back on here. Yeah, I could see somebody being a full-time moderator for this kind of thing. If I had more than like one watcher. I think I need to do this during the daytime and get a following. I only have like 30-something subscribers. Once I have 100 subscribers, I'll probably try to do more. I don't know. It's hard to do when you're not famous. And I'm definitely going to try to push my videos some more. I really have a lot of things that I could probably put on video. I just need to film more. It was like a month or so between videos. My last video was about a month and a half. Because I was going to QuakeCon and I moved apartment to a new apartment, and I have a basically a night job, so I can't do stuff during the mornings easily because I sleep all day, and then I'm usually up till from midnight to 5 a.m. is my prime time. So yeah, that's a thing. Once I get a more regular schedule, I want to do at least weekly videos, if not daily. daily is really, really hard. Especially editing. Like, I'm not good at editing, and I'll probably get better at it. But I need to have a format. Like the rest of the channels I've seen have some kind of video format, and my main thing is once I get my printer set up, I'm gonna have to have like a single camera position in my room, and I can't set up at the makerspace because I have to set up and tear down all the time. But I have a perfect part. My new room has a perfect area for filming. The only problem is I need lights, so I need to either buy or find shadow box lights or LED lights that are bright enough that can evenly light my face and the printers. Plus, I need another table to work on. So I'm going to design a printer shelf, and then I'll probably get a folding table that I can use as my workbench, my temporary workbench. But I'd rather have a workbench that's on wheels, so I can roll the workbench away from the shelves. See, I'm gonna have to make this all modular. Like, I want a workbench on the foot of my bed, and then I'll probably have the shelf on the other side of my bed. That way I have kind of room, but like my desk doesn't have much space on it, and can I keep my desk clean? I also need an open area to put my tools. So I need basically one of those like full-size woodworking benches with pegboard. So let's see. It's 1 o'clock, so it's been about an hour. Hey guys, I'm gonna share my live feed video. Because nobody's watching. You guys are gonna see my public Facebook. Just squint. I have a friend that's really into Steven Universe, which it would be amazing if I could 3D print Steven Universe stuff, especially the gems, all the gems and everything else, or even the characters. If I could design the characters, that would be cool. Actually, my friend's husband is a 3D modeler, and he could probably help. I hope this sounds good. I didn't do a test, but the microphone is in the webcam. I'm sure they love me posting on 3D Fab's thing, 3D printing. Oh, cool. What's this one? Okay, generic pie case. I like OpenSCAD, but I think I'm gonna do. I'm gonna go back to doing Fusion 360. I kind of play with it a little bit. I play with SolidWorks. Fusion seems to be like more popular. I do have access to SolidWorks, so. Okay. I'm not gonna trim any of these parts. I shouldn't have to. And it looks like that's not even recommended. Okay, before tightening screws, of course, there's the next step. Push the end stop all the way towards the X carriage as shown in the picture. So that would have been nice to know. They could combine a lot of this stuff. Like a lot of these steps could be, condensed into kind of more logical progression. Of course, it's open source, so I could probably make my own manual, which is what I'm trying to do right now, is by this video. Of course, I don't think anybody wants to watch a 5-hour video just to pick up tips. I think that's as far forward as I'm going to get it. It's going to hit this, click, click, click. Oh my god, there's like literally a millimeter tolerance. There's a millimeter gap between the X carriage and this end stop switch. So there is no room for error on that one. X end stop, check. Click. Make sure that you heard a click sound and that the X stop is triggered, as shown in the picture. Okay, maybe I'm kind of thinking myself ahead of this manual, but I should just read it. Cable management. Okay, my favorite part. Use zip tie to secure the X end stop cable to the X motor cable as close to the motor as possible. Do not over tie the zip tie, or else you can damage the cables, of course. So, easy. Do this. It looks like you don't want to overbend the X end stop here. So, take a zip tie, zip it at the motor base, the base of the motor wires, it looks like. Yeah, not a big deal. Don't want to be picky, it's gonna, zip tie part's gonna go out. So I'm not really good at social media, apparently, and so I should probably get more views with the people that follow me. And the other thing I was thinking of, and I can't do this with OBS, it doesn't seem like, but streaming on Facebook while I'm streaming YouTube live, like I'm only doing YouTube because I can store the videos directly on YouTube. With Facebook Live, like nobody that doesn't have me on Facebook, I could share it publicly, but I'm not gonna have them go to Facebook. I'm gonna have them go to YouTube because all my other videos are on YouTube. So if you know a way to do like simultaneously streaming to 3 different services, I definitely have the bandwidth to do it. So. Okay. Cable wrapping. Use the smallest in diameter spiral wrap throughout the cables. Oh, really? Okay. I really don't think I need a cable tie for that one. But that's cool. It's a small detail. It's gonna protect, it's gonna make it look better though. This is the smallest in diameter. Okay, so there's no zip tie that actually holds, from what I can tell. Yeah. No zip tie to actually hold the cables together. So, let's get this started. No, I'm definitely a fan of ribbon cables. I think ribbon cables are, I don't know if they're a better way to do this, but it's easier because you could just terminate everything at, with connectors. The only thing with that is the, oops. The only problem I have with that is the, it's crosstalk, so you have to make sure that there's no interference or crosstalk with your ribbon cables. So, honestly, shielded Ethernet cables are the best, in my opinion. I know some people that use them for 3D printers, but I don't really like how they look. So, I don't know. I don't think there's any good solution. I only think the only good solution is for using cable chains and just raw twisted pair of wires. This is the Watch Mitch Do Really Tedious Work channel. Not bad. This is honestly way faster to put together. Once I learned how to do this, like I bet putting these things together would be no more than like 4 hours to build one of these. It's really just a lot of tedious like zip, zip, screw, screw. Okay, so x-axis is done. That was probably the simplest thing. Don't be nervous that there isn't a belt yet. We'll get to that later. You can continue by assembling z-axis in the next chapter. Oh god. Okay. So I'm going to put the X carriage to the side here along with my Y carriage. So we got all my completed parts. Make sure I'm still in frame. Okay. You can see a lot, can't you? Power supply. Here's my papers. Okay. This next step, I'm going to use my screwdriver and some of these wrench thingies and my pliers and these wrench thingies and this thingy. So pretty much all the tools. And we have an extra zip tie. Cool. Oh boy, printed parts. Z-axis. Oh, that's cool. Okay, I'm gonna pause the stream for a bit, get some drink, and we'll be back. Am I still alive? I'm still alive. Good. Stopping the stream.